Hello everyone, welcome to the second section lecture of the modern survey. Today we are going to study the global positioning system, that is GPS. In the previous class we saw the brief explanation on the remote sensing. What is remote sensing, how it works, what are its principles, what is the working of it, and where it is used, right? So today we will study about global positioning system, that is GPS. Right? We will be studying global positioning system, right? Fundamentals and working principles. Receivers, right? So first we will understand what is a GPS or a global positioning system, right? And also we will study advantages and disadvantages also today here. Right? GPS, you might heard about GPS, right? In every smartphone there is a GPS. Now what does this GPS does? This GPS will tell you where exactly you are on the earth, right? It shows you the location with latitude and departure, or latitude and longitude. With the help of those, it will tell you it's your location of that device, wherever it might be. It is not only you, it is your device you're holding, right? So this global positioning system is of US, right? So we'll go in deep. This was a small brief definition for it, right? It will tell you to find out your location. It will help you. GPS, that is global positioning systems, GPS, are used for calculation of latitude, longitude and latitude of many users, n number of users, right? Today everyone has smartphones, right? So there are a lot of smartphones in the world. So every user, every mobile smartphone has a GPS in it. So this GPS receiver will receive the signals from the satellites, right? So with the help of the satellites, the signals, we can find the location of ourselves, right? For many centuries, the sun, stars were used for navigation. Whenever we were going for some expedition, right? Whenever we were going for the unknown places, so that time our navigation system was the stars, the moon, the celestial bodies, right? Those were our navigation, right? Those were our references through which we were moving forward or expediting, right? So on the land, surveyors and the explorers used to use familiar reference points to base their measurements, right? To reference to the base their measurements or find their way, right? These methods worked well within certain limitations, like non-visibility of the sun and the stars when it is not cloudy. This moon, stars, when you were using as a reference point, right? Whenever they were visible, it was very easy, right? It was easy to navigate. But if there was a cloudy season, if there was a rainy season, then these stars and moons and the celestial bodies were not visible to us. So at that time it becomes very difficult to know our location and to know our destination location, right? So this GPS, how it works, what it is, we saw what it is. Now we will also see how it works also. GPS is a had begun in 1970. This was actually built for the defense purpose, to know the exact locations of their army peoples, the defense people who are on the war or in the some areas where there is no network connection, communication systems were not there. So in that case, this would become to know the location of their people, defense peoples. It was used. The concept promised to fulfill all the requirements, such as finding the positional values accurately at any time on the Earth's surface at any time, right, in all weather conditions. Right? So it would be used in everywhere, anytime, anywhere, at any weather conditions. Right? So for that it was produced by Department of Defense of US in 1970. Right? So this GPS has 3 segments. Okay, GPS has 3 segments. First is your user segment, where the user is standing with a GPS machine. Right? There is second segment, that is space segment, where the satellites will be sending the signals to you. Right? We'll go in deep. First understand what it is. Then next is the control stations. Right? So what happens is, as the development of satellites, right, happened, as we were started sending the satellites on the space, so that helped us to develop this system. Right? So whenever, if you have a GPS receiver in your hand and you on it, right, if you want to know the locations, at least 3 satellites should be the receiver should get the signals from at least 3 satellites. If you don't get the signals from at least minimum 3 satellites, then your location cannot be found out. Right? So that is a condition here. So whenever you on the receiver of a GPS on the ground of Earth surface, right, these satellites are on the space. So as you on it, right, if you receive 3 satellite signals from the satellites into your receiver, then the receiver machine or GPS, the receiver, will do the calculations. Right? So that calculation will be done by that receiver, and you will get your location at where you are. Right? So how this happens? How this calculation happens? This all things we'll study. Right? So we'll understand that GPS has 3 segments. Right? It has 3 segments. So that is your user segment, space segment, and your control segment. Right? So what does the satellite send in those signals? What will be there? We'll see. In that, there will be a timing at which the signal has been sent. The point where the signal is sent from the satellite, that timing has been recorded in that signal. Okay. So what happens? We know how to calculate the distance. Right? So as we send the signals from the satellite, the timer is started. As it reaches the ground to the receiver will record that time. It will see how much time it took from the point of transmitting to receiving. Suppose it took 8 seconds from the satellite to come down to the receiver. It took 8 seconds. And what type of signal it is? It is a electromagnetic signal. Right? It might be a radio wave, it might be a microwave, or it might be any other wave. But mostly we use microwave or radio wave. So that are electromagnetic radiation. So these electromagnetic waves have a speed of what? Of light. They have a speed of light. So we know the time, we know the speed. So when you multiply it, you will get a distance. Because speed is what? Distance upon time. So when you distance upon time into time you do, time gets cancelled. Right? If this is the time required t into speed. What is the speed? Speed is distance upon time, right? So you know the time and time gets cancelled. So what remains? Remains distance. So you got the distance from the satellite, right? So that distance you get, right? With the help of this, because of 3 satellite signals, right? You are easily detected. Once you are detected, you will get the latitude and longitude with the reference of the maps. The satellite has its own calculations and the maps with it. So with that inbuilt maps, it will exactly point out your uh, location, right? So that location will be calculated in your GPS receiver. So that is the working of your user and the satellite segment. But what is the use of control segment? We know that it sends the signal at a light of speed of light. It will measure the time required from 3 satellites. It will measure and it will calculate the mathematical equations. It will calculate. It will do its own, right? And then it will give you the location. But what is the use of control segment here? Control segment checks whether the satellite's health is good or not, whether it is in good condition or not, right? Second, it will also see whether the satellite is sending a wrong signal or not, right? Whether the satellite is sending a wrong signal or not. As the user end receives the signal, same way the control segment also receives the signal from the satellite, and it will verify the health of the satellite. It will check whether the timings and the signal sends are correct or not. It will, if there are any errors, then it will rectify it by sending the signal again to the satellites to change their basic details, right? That is the work of the control segment. It will control the satellites and it will check whether the signals which are sent by these satellites are correct or not, and also checks the health of the. It will monitor the health of the satellites, whether the satellite is in proper condition or not. That it will check in the control segment, right? The same thing what I told you here. Space segment, user segment and control segment. Space segment in this GPS, as I said, this is made by this GPS, or it is not a name of a any navigation system. US has its own navigation system and it has given its name as a GPS, that is Global Positioning System. Our India has NAVIC, right? India has NAVIC with the 7 satellites. It doesn't cover whole of world, right? But this US Global Positioning System will cover whole Earth with 24 satellites, right? In its own orbit of 20,200 kilometers above the Earth's surface. They are above the Earth's surface at what distance? They are at a distance of 20,200 kilometers. At that distance, these satellites are moving, right? So this name GPS is not a name of the navigation. It is name given by the US to their navigation system. So we also have NAVIC. Europe has GLONASS. Russia has GLONASS, right? Europe has Galileo. So that are the names given to their navigation system, right? So don't confuse with yourself, right? The user segment consists of receiver, which is in the handheld type or mounted type in a vehicle, right? The control segment consists of 5 ground stations. In the case of American GPS system, because it has 24 satellites all over the world, so to control all the 24 satellites, they have all over the world they have 5 ground stations. How many? 5 ground stations are located all around the world, which monitors the proper functioning of GPS, whether it is working properly or not. To check these systems, control stations are being provided. The basics of GPS is triangulation from satellites, right? To triangulate a GPS receiver measures the distance using traveling time of a radio signal, right? It travels at what speed? It will travel at the speed of light, and it will also measure the distance. Through that, you can calculate the distance, right? The whole idea behind the GPS is to use the satellite in the space as a reference point for the location anywhere on the Earth. The satellite position of the satellite becomes a reference point through which we will find out the R point on the earth. Right? Same thing I will try to say you that the signals sent by purple color signals are sent by the satellites, okay, all over the world, where there is master station and control stations and user segment. Right? Master station will control the monitoring stations. It will look after the monitor stations, and it has sub ground stations, right? To check these stations, or master stations and control monitor stations will check, right? These monitor stations will receive the signals and they will send these signals to the control segment, that is your master station. They will verify and they will send the if there are any defects or any doubt problem in the signals, they will send the corrected signals, right? They will do all the corrections that are required if there are any errors, right? And once it is corrected, then the user can use that signal to find their location, right? This is how it works. That is how the GPS works, right? Working principle of GPS. The idea behind the GPS is rather simple. If the distance from the point on the earth to 3 GPS satellites are known along with the satellite location, then the location of the point can be determined by simply applying the concept of resection. If we know this, if we know the location of the satellites, with the help of the 3 satellites of GPS, we can find out the location of ourselves or of the locator, right? Of the receiver, right? With the help of what? Resection. GPS satellite continuously transmits the microwave radio signals composed of 2 carriers, 2 codes and navigation message. So all these messages are in the microwave radio signals. These messages are being sent. The time, the time, the date, right? And all the other required location of the satellites. All this is being put into in this message, and it is continuously transmitting, because somewhere or the other some person will be using GPS. So for that, it is continuously transmitting the signals. When the GPS receiver acquires the signal through the antenna, once the receiver acquires the signals, it will be processed by using inbuilt software, because the receiver will be having a software in the GPS user machine. The partial outcome of the signal processing consists of a distance to the GPS satellites through digital codes and satellite coordinates through the navigation codes. What will be there in the digital codes? The distance, right? At what distance it is, right? At what distance it is, that distance has been written, and in the navigation message it will be coordinates of satellite, right? The location of this satellite will be there. In one, it will be in the codes, it will be the distance, and in the navigation message it will be the location of the satellites. With reference to that, we found out the R location, right? GPS receiver calculates the position of the object in 2 dimensions or 3 dimensions space using the mathematical process called trilateration. This method, right? This method is used to determine the position of an object by measuring the distance from the other objects with a known location, right? We find the location of one object with respect to the another object whose location is known to us, right? Now receiver, what are the works of the receiver? The most important thing is the GPS receiver. There are different types of GPS receivers available in the market, but only a few of them are suitable for GPS surveying. GPS surveying receivers are usually equipped with the extra battery charger, data storage devices, an external antenna, and a tripod for a mounting device. Right? GPS is a one-way ranging system in which the receiver determines its location by processing the range of measurement of GPS satellites, and hence the GPS receiver has to include all the hardware and software needed to determine the GPS receiver positions, velocity, and time data, and other derived parameters as required. Right? Also, the GPS receiver must have a provisions for interfacing it with the other navigation systems to provide accurate navigation. So he has to look for the various things, but nowadays it is very fast and it is all automatic. So you need not enter anything, just on the receiver get the signals, and you will the processing will be done, and you will get the location. Right? So what are the advantages of it? Okay, what are the advantages of GPS? The intervisibility. Right, the first one is the intervisibility between the station points or the survey points are not necessary. Right, your station point and your surveying point need not be visible. Right, GPS can be used in the any weather conditions, day or night. This enables the GPS surveying to be carried out over an extended period at any time of the year without restrictions. Right, it is very easy to use. Right, these are all advantages. Right, simple operations and user friendly it is. It gives quick results, produce the results with very high geodetic accuracy. Right, limited calculations and tabulations works required. Actually, there is no requirement of calculations and tabulations. It's only large area can be surveyed in a short distance. Right, can survey large area in a shorter distance. The disadvantages are no sky obstructions can be tolerated. There should not be any hindrance, because the signals which are coming from the satellite will be absorbed by those obstructions and the signal becomes weak. So that cannot be, because of that we can't determine the location of our GPS receiver. Cannot be used for the site for which underground or within structures. It cannot be used underground or it should be outside in the open air. Right? GPS surveying is generally targeted to satisfy the specific survey needed. It is not for all the surveys. It cannot be used for all types of surveys. It is used for specific type of surveys. Right? High capital cost for GPS instrumentation. The receiver, the instrument that is required, the receiver GPS machine, those are very costly, and it requires a skill to use it, to understand what it is trying to say. Right? These are your disadvantages. So we saw what is GPS. Right? We saw how it works. Right? We saw various types of segments in it. Right? We saw how what are the advantages of it, advantages of GPS, and we saw the disadvantages of GPS. Right? So this completes your second lecture.